Hi, I'm Margaret Paulsgrove. I work here at M5. Welcome to Circuits and Code 2018.
Welcome to Circuits and Code. It's December 2018. We've got a very full house today. People have traveled 2-3 hours to get here. A lot of local people are here. It's very cool. We've got first year lab projects. We've got some projects that people have been working on for a year or two. It's cool. It's a total geek out, no embarrassment, geek fest.
So I'm Ansh Chandra.
Yeah, this bottom top.
This is my project. So what it basically does is it records the sound from the mic of my computer and analyzes it, performs like frequency processing, and maps different frequencies to 3 colors. So its base is red, mids are green, and highs are blue. And then it calculates that, sends the data over Wi-Fi to this chip here. This is an ESP8266 Wi-Fi module, and this module acts as a controller for this LED strip.
So, what kind of music do you want us to play?
You want some low stuff?
We can play some SpongeBob distorted crap, or we can play this. So I'm Jeremy Yu.
I'm Sam Morrell. Yeah, so the amplifier takes the digital signal from his phone and steps it up to greater power so it can be played at the right volume through this big speaker.
We have an op-amp, which we were going to use 741, but Barry didn't like 741, so we had to change out for 5532, any 55532. It's very efficient, it doesn't heat up. I can still touch the MOSFET, which is like where the amplifier. Ow!
It's not bad.
It's not bad.
Alright. Hi, so my name is Tucker, and this is my project.
I didn't get a whole lot of time for organic.
Right now, I'm building the temperature and humidity sensor, which is reporting the current time of the temperature and humidity of the M5's makerspace area to the cloud, and then send directly to the user that subscribes to the M5 IoT system.
Hi, I'm Sai, and my project is to add the speed sensors and odometer readings to the skateboard. So these skateboards already have Hall effect sensors in the wheel built in. So I use an Arduino to tap into these sensors, and when I spin the skateboards, like the display here will show you the speed and the odometer reading.
I am Margaret Paulsgrove. This is the very lazy Susan. Isn't she cute? So basically what this is a 3-tiered rotating platform in which all 3 tiers can rotate independently of each other. Some notable pieces on this are the fact that the bearing holders, gears, and this support for the second tier are all 3D printed. You can see some of my OpenSCAD documents right here. It's got an Arduino microcontroller, and it's just got about like 9 lines of code that say I have 3 servos, I'm going to use 3 pins, and all of them need to rotate. It's very simple. My next progression of this is going to include an IR remote and like some nicer platforms, so that way it's a little bit more load bearing and a little bit more lazy.
Hi, I'm Connor. I'm a legal studies major. I'm here for my friend, but this is really cool. There's some crazy stuff here. It's kind of blowing my mind. Like, that's a robot. It's just a robot.
Okay, so here I'm Nikhil, and basically our project's an LED strip that's controlled with the joystick, and whatever direction I put the color changes. So if I move it up, it turns red, and if I move it down, it turns blue, and to the left yellow, to the right green.
I'm Chris Raff.
And I'm Alex Lamson.
And this is our 8x8x8 LED cube.
It uses an ESP8266 microcontroller, which we're not using the Wi-Fi from. We're just using the fact that it has a really fast processor. And the way that it works is it drives all these neopixels, through-hole neopixels. They're all wired electrically in parallel, and then data-wise, we run a wire that goes through the entire cube, and the data is running in series. And basically we programmed a bunch of demos, and right now it's just cycling through all those demos. This is our favorite demo for sure. This one.
Everyone loves this one.
Yeah, because it looks really cool. Alright, so I'm Jeremy Parody. I've been working on these structures. I'm interested in robotic assembly of digital materials, and
digital materials are like materials where you've got discrete units. So I've been playing around with different structures to see which ones lend themselves nicely to robotic assembly. So this one's interesting because it's all the same part. So it's just this like rectangle piece. The back off. And this could be cut from a laser cutter, but we don't have a laser cutter right now, so these are just 3D printed. But what's interesting about this is we could flat pack these and just stack them like a Pez dispenser.
My name's Cal Little. I'm Andrew Hall. So our project uses an electric piano that outputs digital signal in the form of a MIDI, and then we take that MIDI value and convert it to an integer, so it's easier to work with. And then we use a few if loops to say if we get this number, light up these certain lights. So for example, this key will light up these lights, and this key lights up these lights. So if we play a certain song, it'll give us a light show. So Andrew here can play a song.
Get back skating! Whether it's done
Okay, hi, I'm Tammy.
I'm Sanjana.
And this is our countdown clock. So for our project, the user gets to input any 4-digit number for the LED display. So let's say I put 10 seconds in the clock. I'm alive! So it's going to count down to 10 for 10 seconds. Yeah, and as you can see, the LED lights up when the counting down is done. Yeah, that's our project.
I've never seen hi, I'm Meganeko.
I'm Hakan.
And our project is the digital audio compressor.
So what the digital audio compressor does is if you look at this graph, we have the blue, which is the original waveform, and this whole thing is a song. And the green is the output. So what it accomplishes is in the low volume parts of the song, it doesn't change the output much, but in the higher volume, it does compress it significantly. So it allows us to decrease the dynamic range of the audio by a lot.
And this is the time, and that's the magnet.
Yeah.
Alrighty, so I'm Richard Witherell. I don't know where my partner went. This is a soundboard. So this is the M4 board. That's where it stores all the wave files that it uses. This is the keypad that we use for input. Push a key, it plays a sound that corresponds to it. This is the 8 ohm amp that we're using. This is an 8 ohm speaker.
Yeah. So I'm Marilyn. I'm Stephanie, and this is a color changing RGB LED with MIDI. So we take the MIDI signal from this MIDI controller here. It goes into our computer, and then based on the note that you press, this RGB changes color.
I'm Owen DeClean.
I'm Itis Jokovenis.
And our project is a radial drawing machine. Now our inspiration was, we took a regular printer which uses Cartesian coordinates, that's X and Y. We wanted to change it so that it used polar coordinates, that's R and theta. So if you look here, we have controls that are able to adjust your radius and are able to adjust your angle. And from that, you can draw some abstract designs and patterns.
I think it's going really well. Like some of these freshmen, I'm really impressed with what they've done.
So I'm Roshan Chetty. I'm Nick. And this is our project. This is called an obstacle avoidance car. So what it does is when you put it down, it'll move forward. But when you have a distance less than 35 centimeters, then it'll stop and it'll turn right until it finds a distance to be greater than 35 centimeters. So it'll just move up ahead, and then we just keep on stopping it.
Alright, so this is basically the model of a house automated system wherein we have like made use of the interior lights and the garage that will open on its own with the help of the ultrasonic sensor. So basically when you enter like a particular distance, so this gate like opens on its own. So like move it and it opens on its own, you see?
Yeah, so this is an RFID lock and this is a lever of a door. So what basically RFIDs are cards with chips which have a code in them. So if you have a card which is like the code which is registered, you can go and it opens the mechanism for your door. And we have also set it to like lock after 5 seconds. So that does it. And if someone tries like some other RFID which is not registered, it won't open.
Hi, I'm Omri Shivi, and I tried to make a drawing machine, attempted to. Right now it's trying to draw, what's your name again?
Sean.
Sean's beautiful drawing of the meme, the awesome face. And it's working out really well actually right now. This is like it's had some catastrophic failures in previous runs. Okay, the other eye isn't really working. This is just on time. The machine was done in Python, but in my drawing software was done in Java. Here you go, Sean. Your beautiful drawing. Isn't that? Yeah, I've give him a round of applause.
I'm Tony.
I'm Justin. And this is Smart Mirror. So we're using a two-way mirror here. Backlighting is from an old TV that we found. We got a PIR motion sensor that will turn off the LED lights in the back after 60 seconds. And then if it senses an infrared, a change in infrared, it'll turn the LEDs back on, turn the mirror back on pretty much. Yeah.
Hi, I'm Weishan. So my project is a sound reactive LED lamp, and there's a PVC pipe inside of a frosted glass container with LED strips wrapped around the PVC pipe, and there's a mic which picks up the sound from anywhere really, and the LEDs react to the amplitude of the sound.
Hi, my name's Dylan, and this is my robotic mimic arm that I designed using an Arduino. So the main components is I have potentiometers here, and the potentiometers control each of the servos on the arm that I have. So you notice this potentiometer here, when I turn this, it controls the servo that is right here. So I have 6 potentiometers, 6 servos. Each one does a different function, so I can move it back and forth. I can move it up and down like this. I can turn the jaw, and then I can control if the jaw opens or closes. And I'm basically mapping the analog signal from the potentiometers into digital signals of degree value so that the servo can understand it easier.
Oh, I should do like a